Hey folks, welcome back. Mr. G here again. This is the second video in the mini series on basic measurements using the Keysight meter. In this little series, I'm going to look at measuring voltage with the Keysight. So, I have my little resistor circuit hooked up. I have my power supply hooked up. And now I'm going to take some voltage measurements. So there are different types of measurements. The first kind of measurement is of the total voltage going into the circuit. So coming out of the power supply, what is my voltage? Then the second set of measurements I'm going to take is what is the voltage drop across each of the resistors in my circuit. So to measure voltage, again, upper right hand corner, that input there has the little voltage symbol, a little V, so I'm going to put the meter in there, and then the black one is going to go in the one directly below it. Again, that is my common for this meter. Measuring the source or input voltage into a circuit, red to red, black to black, and we are measuring DC voltage DC. So the input voltage, so my source voltage for this little circuit is 10.067 volts. If I change the input voltage on my power supply, you'll see that the value of the voltage goes up and down. So that is a live measurement, and I'm going to set it back to approximately 10 volts. There we go. So I'm at 10.0142 volts, and that is DC. So that is measuring the total voltage coming into the circuit. Now what I'm going to do is I'm going to measure the voltage across each of the components. The key here is to keep the red probe closest to the red input, so the positive to the positive. The black is going to be closest to the black side. So I'm going to take this resistor right here. This is my 51 kilo ohm resistor. I'm going to take the red and go to one side, and that's the side that's closest to the red. And then I'm going to take the black and I'm going to clip it onto the other side of the resistor, and I'm going to read 8.85 volts across this resistor. Again, you're going to take the red and connect it to the red side. You're going to take the black and connect it to the side of the resistor that's closest to the black. And again, I am reading 8.85 volts of DC. Then I'm going to go to the other resistors. So this one here is my 20 kilo ohm resistor. And again, I'm going to put the red probe closest to the red side, the black probe closest to the black side, and I am measuring 1.157 volts of DC. I'm now going to go across the third resistor, and this is my 10 kilo ohm resistor. Now the 10 kilo ohm resistor and the 20 kilo ohm resistor are actually in parallel, so they are going to share the same voltage. So again, red goes closest to the red side, black goes closest to the black side, and I'm getting 1.1569 volts DC. So the same voltage across the 10 kilo ohm and the 20 kilo ohm because they are in parallel in my circuit. So one more time, the total voltage right at the supply input, 10.0138 volts. The voltage across this first resistor, 8.85 volts, and a voltage across the other two resistors, 1.157 1.157 because they are in parallel. Voltage is measured across a component, and keep the red probe closest to the red input sides, the positive side of the probe. If you get them backwards, you're going to get a negative reading on your meter. It doesn't mean it's bad. It just means that the meter is expecting the electricity to enter in on the positive side. You have it entering in on the black lead into the meter. So electricity, when it's flowing backwards into the meter, it gives you a negative input. So negative doesn't mean bad, negative doesn't mean small, negative means opposite direction.